Okay. Hi everybody, and a very warm welcome to this launch webinar. This is a webinar to launch the SFC hackathon. It's our first Zindi Weekends hackathon. It is a credit repayment challenge. We're really excited to be launching Zindi Weekends again, and you can look forward to a new Zindi Weekends hackathon once a month for the next few months. In order to drum up some excitement and to help you guys out a little bit, we're hosting this first this launch webinar. The hackathon will run all weekend, but right now we're going to have a quick chat with Mr. Muad Al Fatoui from AFC. He's the VP of AFC, which is the company hosting this challenge and the company that's provided us with the data. He's going to chat with Selena Lee, our CEO, and then we're going to have a live coding session with Cedric Manouan, who is a data scientist at Zindi, as well as a top competitor at Zindi and one of our ambassadors. So we hope that you enjoy this session. Please feel free to ask questions using the YouTube live chat, and we'll do our best to answer any of those questions that you do have. I'm going to hand over now to Selena and Muad.
Cool. Thank you, Paul. Hi, Muad.
Hi, Selena. How are you?
Good. Thank you. And welcome to the Zindi community out there joining us for Zindi Weekends. We're so excited to have this first Zindi Weekends. And we're focusing on a really important challenge, which is renewable energy, solar energy. And we're so excited to partner with Muad and the team at Solar Frontiers Capital. So Muad, so we're gonna take 10 to 15 minutes to just have a chat and get to know a bit more about what you guys do. So yeah, Muad, could you tell us a bit about yourself and a bit about what you do at Solar Frontiers Capital?
Yeah, so first of all, I want to thank Zindi for organizing this competition. And also I want to thank all the participants for competing in this event. I hope you all enjoy this challenge and learn a lot from it. So in terms of my background, so I have an engineering background, engineering degree. I've always worked in the financial industry. I have now more than 10 years of experience in the financial industry across different countries. So I worked in the US, in France, and I'm now based in London. So more on a personal level, I'm born and raised in France, but I have African origins. And so I've always wanted to give back to my roots pretty much. And so I want to, by doing that, I want to help the African business grow in general. And so
where is your family from?
From Morocco.
Very nice. We have a lot of Zindians in Morocco.
Yeah, happy. Yeah, so I see myself as African. Even in France, I was born, as I said, I grew up in the suburbs of Paris, and it's like all mixed up Africans from all over Africa. So mostly Western Africa because they're French speaking, but also North Africa and some from Eastern Africa as well. So I feel fully African. Yeah, so at African Frontier Capital, we are an impact investment company. We focus on African businesses through our subsidiary Solar Frontier Capital. We focus on renewable energy in Africa, and more specifically in PAYGo solar home systems. So what we try to do really is bring together AI techniques and traditional structured finance to finance projects in Africa.
Sure. No, that's amazing. So for some of the people out there who haven't heard about pay-as-you-go solar, can you tell us a bit about how that works. What is it?
Yeah, so basically how it works is customers can buy a package on credit. So a package includes a solar panel. Depending on the package, it will be a bigger or small package, a small solar panel. Sorry. Within the package, you'll have a battery. Same within different package, you'll have different sizes of battery, and then you can have within the package a bulb or several bulbs. The customer can also upgrade the package to buy a TV, for example. There's like pay-as-you-go company started including also mobile phones. So it's really like really helping like the electrification in Africa, but also like entertainment with TV and mobile phones. So how it works is the client pays as he needs electricity. So once the customer pays off the contract, the system is unlocked and the customer has free electricity afterwards.
So it means that they pay a small kind of down payment, right, on the system, and then after that, how do they pay going forward? Is it day to day, month to month?
Yeah, so the customer, how it works is at the beginning he or she will pay a deposit. Within the deposit, there'll be a few days of electricity, what we call tokens, and once these tokens expire, the customer can buy more tokens. It really depends on the customer. They can buy either one token, so day by day, or like several tokens in one chunk. It's really dependent on the customer profile, also the customer needs. For example, we'll have farmers that have incomes that are more like quarterly incomes, or depending on on a yearly income. So they'll pay electricity for a whole year. Or a customer that's struggling, he'll prefer to pay on a daily basis. It really we really adapt the payments profile.
Right. It's quite flexible.
Yeah.
Right.
And once the customer stops paying, the system is locked. But once the customer starts paying again, the system is unlocked. And as I said earlier, once the contract is fully paid, the customer owns the system, and he or she has free electricity afterwards.
Wow. So essentially, once they've paid for the kit, then it's unlimited use from there.
Yeah, correct.
Cool. And so what is I mean, for years I've been hearing about PAYGo. I've come across different companies that are working in this sector. I think it's a really innovative model. What is the impact that this type of model is having in Africa?
So we noticed several impacts that it has on Africa. Is one, that it improves community health. Customers who didn't have PAYGo systems before were using, like for example, kerosene lamps. So some ways of having electricity that are polluting their own houses. So in terms of health, we saw an improvement. In terms of like fostering, it also fosters self-employment, because the customers can be personal customers, so like farmers, and also businesses. So for example, a lady in Africa wants to open a shop. She will be able to contract pay-as-you-go solar home system for her shop, and she'll be able to remain open also overnight, and all using this system. So we noticed that as well. It also provide education in general. Like in some remote places in Africa, unfortunately, they have like one lamp system for the whole house. So if a kid wants to study in a different room, or like they'll have to either be near the lamp or not study at all. And we noticed that with like the system having several lamps, several bulbs, as I said earlier, they'll be able to stay in a room and study in a quiet room in their house. But also, as I said just earlier, our customers can be businesses, but also can be schools. And we noticed that some schools can do evening classes, which brings a lot to the community. In terms of like pay as you go, it also brings electricity where there is no electricity. So unfortunately, some electrification ratios in some remote places in Africa are low, and having this pay as you go option brings electricity to some remote places in villages or in the countryside out there in Africa. And the last point I'm thinking of is improved lives in general. As I said earlier, a customer can upgrade and have a TV or a mobile phone. That's an option that they didn't have before with the kerosene system that they had at home. So I think it's bringing a lot to the community, and we're trying to improve that day by day.
Yeah, definitely. Do you have a sense of how the price I mean, well, you were saying that, maybe it's opening up spaces that didn't exist before, access to energy that didn't exist before. But if you compare, minute to minute or hour to hour of kerosene light versus a solar light, is this a more affordable option as well?
Yes, definitely. So in terms of price, is cheaper, but also, as I said earlier, is when they pay off their contract, they own the product and they have free electricity. So
yeah,
on the long term, definitely better.
Amazing. Yeah. So the data set that you've provided the community for this challenge, can you tell us a bit about, I know that there's a few different products in there. You don't have to get into the details of what the product is exactly, but I guess, what are the types of terms that we'll be looking at? Yeah, tell us a bit about what's in the data.
So in the data, you'll see contracts data. So you'll see data at the customer level, so the age, the gender, but you also see data regarding the contract, so the value, the start date, and so on and so forth. You'll see payments history, so how the customer paid over time. But I think an important point to stress on this type of product is the term, is because you'll see a term, but it's a hypothetical term, in a sense that when the customer signs the contract, he agrees on a hypothetical term, saying, if I pay day by day, the term will be a certain date. But since it's a pay-as-you-go, by definition, the customer pays only when he needs electricity. We notice that the term is not always the actual term. And so you'll see in the data that the term can be, the actual term can be a bit later than the hypothetical term. We like to look at data in general, like looking at 2 times the term or 3 times the term to see how the customer pays. Because definitely a customer that doesn't pay at term doesn't mean that he or she won't pay off the contract.
Right.
The best way to do it is looking at like a multiple of term to see how the customer behaves.
Right. So the term is very much hypothetical, as in someone who pays every single day and never. And I guess one of the important points that I think maybe we didn't mention is that essentially when they use all their tokens and there's no more tokens, the device basically shuts off, right? So it means that so it's not a traditional loan where you have to pay all the time, but like you're saying, you pay when you need the device, and hopefully at some point they get to own the whole device once they've paid everything.
Yes, correctly. Yes. So if the customer stops paying, it will lock the device, and once he starts paying again, it will unlock the device again.
Yeah, sure. And so just quickly, I mean, I guess lastly, it's been, it's so exciting to have all of these data scientists across Africa working on this problem now. What would this solution, so we're actually looking at a time series type of problem, but being able to predict how people will pay, what does that help you with? How will this solution help the business?
So what's important to know is if I simplify our process, is basically buying contracts receivable, packaging them into a vehicle and selling that to investors. That's like a simplified version of the process. On the first step, buying the contracts receivable, for us, it's really important that if, for example, in the case of the competition, we have 50,000 contracts, who are the customers that are going to pay, and who are the customers who are not going to pay off the contract. And for the ones who don't pay off the contract, by how much will they be off? Knowing that is a way for us to give a price on how much we should buy this package. By doing so, we'll be able to package this product, tell our investors that's the probability of having that certain amount, and it will be easier for us to look for investors like internationally.
Sure. Yeah, that makes sense. And essentially, at the end of the day, it'll allow you and all your partners to make this type of technology more accessible, even more. So that's amazing. We're so excited to work with you. That's all the questions I have. But you, all of the data scientists out there, feel free to drop any questions. And also, once the competition gets going, you can drop questions in the discussion board, and Moad or our team will answer them. But Moad, thank you so much. We're so excited to have you on board with this.
Thank you very much.
Paul?
Thank you so much, Moad and Selena. Great to hear a little bit more about the data and about how this hackathon is going to have an impact on renewable energy and on the SDG 7, as we've highlighted already. So up next, we're going to introduce Mr. Cedric Manouan, who's an in-house data scientist at Zindi, as well as a fierce competitor on the Zindi leaderboards. I'm going to hand over now to you, Cedric, and Cedric will take us through a starter notebook that he's worked on for this challenge, as well as giving some ideas about where to go in terms of solving the challenge. Over to you.
Okay, thanks, Paul. Hope everyone you can hear me there. So I'm gonna share my screen now. Yeah, so basically, I'm not gonna solve the problem, but I'm gonna share with you some kind of insights for you to start. So basically, here is the basic structure of the project folder I'm using now. So you should be able to get at least more than 4 files: the metadata file, the sample solution, the test, the train, and the variable definition file. So basically, has the previous people said, this is a problem. Like, you should be able to predict like the different amounts that a given customer should be able to pay for like next time steps. So basically, for this competition, we use like 6 future steps for you to predict. So you will basically start building your model on historical data and then try to predict the next or the future payments for a given customer. So let me just go through this notebook. So yeah, I try to help you with some kind of interesting helpers function. So basically, you could start and then try to like spend your time on modeling. So here I load the different files that you will be able to download on the platform. And then I do like a small exploratory data analysis for you, yeah, to get the trends or some insights. So here you can be able to see the different variables you can find in the train file, and yeah, try to see the different statistics from that basic files. Also, yeah, do the same for the other files so that you can then see the different variables there. So the next part is like treating the missing values and other values like that. So basically you can see that on the train and in the test files, you don't have missing values, but you have in the metadata file. So basically you have like two different data sets. The first data set is the train and test. This is the data you would be using to build your actual model to predict the future payments for a given customer. But you have the remaining information for each contract on the metadata file. So you can see here the registration dates, the deposit, and many other variables that you should be able to use to build like this model which can predict the status of the loan, like if a given customer should be able to pay or not pay. But this should be constrained on some like interesting rules. So as Moat said, basically this is not like a usual loan repayment problem, because you can have people paying maybe 2 or 3 times after the term, and then you should be able to capture that particular stuff to get your model good at predicting stuff like that. So yeah, here what I do is like I just I did a basic visualization. So basically this variable is like something I just computed myself to get this interesting variable to build a model for predicting the status of the loan. So this is computed by just asking this question. So for a given customer, you just look at the last payment date. So this is the rule I just used myself. So you feel free to use whatever you want as rules to identify that particular target for you to build your model. So basically, I use two type of condition to build that particular variable. So for me, a bad payer is someone who's like using you just take all the different payment, all the payment history for a given customer, you sum them. So you have the total value paid by a given customer. And then based on that, you try to look at the last payment value. So let me show you the structure or the rules I use to build that target variable. So basically the question is, did the company or AFC receive a payment after the term date plus a given window? So the window is how much you should, so by what value you should be able to multiply the term to get a fair target, right? So by that expecting date, what is the behavior of the given customer? So you look at first this, and then the total paid amount for or of that particular customer. And then what I did is, if that customer, since we usually don't have like the total amount paid by a given customer by the date we are predicting, you should be able to like use something like percentages or stuff like that. So I use like, if someone paid more than 60% of the total contract value, then I say this person is a good payer, right? So that's basically how I computed that variable. And then there, yeah. So those variable are just like some variable. I'm just trying to look at the different trends and then think about the model I could build to solve the problem. So basically, this is relating to the loan status prediction, right? So I built some helpers function, as I said. So basically, this function would help you convert the categorical variables to integers and then compute some extra like variables, like taking the dates and then compute some interesting features from that. So like extracting month or date or stuff like that. So basically this is what I'm doing here. And yeah, after the pre-processing part, you can see there's no more missing value now. And then yeah, I just compute the feature extraction. And yeah, you can see the different features are just kept here. Then I do the basic training test split to next jump right in my model. So here I just start with basically two models, but I'm gonna focus on that particular model. So the one I called like simple model. So you can build like two kind of models. So a model which is able to take the different variables, like the historical payments and also the other variables you can find in the metadata file, and then try to map them, concatenate them, and compute like two types of outputs. The first one will be the different payment for the next month. So for the competition, I said we used the next step number equals to 6. So this model should be able to predict the next 6 payments of a given customer and also output the status of that particular customer. But for this notebook, since we just score your solution on the different payment prediction you do, I'm just gonna focus in on that particular part. So basically, I just use a regression model. So I just take all the payments, the historical payments, since every customer don't really have the same payment. What I do is try to add some padding values and then go through my model and then have the prediction as output. So basically, this is the architecture I'm using. This is a really simple architecture. So yeah, here I just run for like 2 epochs. So you can see that this model is not doing that well. And then here is the evaluation part. So basically, your trained model will be used to like make predictions or forecast the next payment of a given customer. So I just build that data set and then try to look at the shapes of the different files so that I can just go through my predict function and then output like for each customer 6 values, and then I use those 6 values to build my submission file. So basically, this is how your submission file should look like. You have like for a given customer, I mean, let me try and equals 6. Then. Oh yeah, sorry. So I just run the cells and then I'm gonna use that particular file. So SS. So basically, here is how your submission file should look like. So here you can see for the first 6 row, you have one customer. So this is the same ID, but prediction for different months. So basically here is the way you should be able to make your predictions and then save your prediction. Please make sure you're not like saving the IDs for your solution to be accepted on the platform. So yeah, I think this is a really straightforward notebook, even though I think those models I'm building here are not that good at solving the task. So yeah, here is your task to do now.
Cool, thanks, Cedric. Do you there might be some questions from the audience listening. If anybody listening has some questions, now you can start to ask them. And then if there aren't any questions, Cedric, there we go. We have a question. Let me just show that. Will the notebook be available for download?
Yeah. Basically, this is the starter notebook. So we're gonna share this notebook with all the participants.
Okay, fantastic. So this is the starter notebook that will be downloadable on the Zindi page. Cool, thank you for that. If there are other questions, I mean, are there, from your side, are there more, I guess, more things that you'd like to try, a few different approaches, or some more exploration of the data that you'd be interested in going through?
Yeah, sure. Basically, I am like approaching this problem as a regression problem, which is not like the best way of dealing with time series. Basically, we have a data set which is a time series. So for each date, we have a given value, which is the payment for that customer. So what you could use to solve this problem should be like something like a sequence model. So maybe an LSTM or a sequence to sequence model, which can like try to extract information from the historical payment and then compute the next values based on that knowledge, based on that event captured from the historical payment. So basically, you could start using a sequence model like deep learning model if you want. But yeah, these are some of the different ideas I would be interested in.
Okay, cool. And do you think with a hackathon that's running for just over the weekend, do you think a deep learning approach would be effective in such a short time frame?
Yeah, it's really depends on how well people are doing. So basically, for that particular problem, you don't have like to just like train a transformer based model or really sophisticated architecture, right? Because the main task here is to be good at predicting values. So basically, regression model could work for that, but to be, on top, you should definitely try to look at like how to use time series data and map them to sequence model. Even though this is not, it's not like a really big deep learning model, but yeah, this is maybe the most interesting kind of model you should be like able to use to get better scores.
Okay, that's a great tip. Thank you. I hope people will be able to put that to use. Okay, I don't see any other questions from the chat. I think then, if there aren't any further questions, I think we can wrap this up and call it a day and let our competitors get to coding. So I'd like to say a big thank you to Cedric, and a thank you to Moad, and a thank you to Selena for being present here. This has been an experiment for us to see the kind of interest. I hope this has been valuable for you all. If you do have questions, please do ask them on the discussion forum, or even in the comments of this YouTube video, and we will try and answer them as best we can. The competition is now live, so you can join. There's the link to the competition down at the bottom of the screen. We'll also add the link to the description in this video. Otherwise, you can follow us on any of our social media platforms to get to the video. So that all that is left for me is to say once again a very big thank you to all of you for tuning in, and happy coding. Best of luck for the hackathon. The hackathon closes at midnight on Sunday. You have 60 hours. Cheers, everybody.